Hello, so let's start with today's problem. X-rays of 4 angstrom wavelength falls on electron cloud and gets scattered. Determine maximum change in kinetic energy of electron, velocity of electron, and what is given is h upon m0c value, which is 0.024 angstrom. Planck's constant h is given 6.6 into 10 raised to minus 34 joules second, and velocity of light is given. This question was asked in JAM GP 2009. So let's start. We know that formula for Compton shift is delta lambda equals to h upon m0c into 1 minus cos phi. So what is asked is determine maximum change in kinetic energy of electron and velocity of electron. So maximum change in kinetic energy, it corresponds to maximum change in wavelength. So there will be maximum change in kinetic energy when there will be maximum change in wavelength. So we know that there is a maximum change in Compton shift, maximum change in wavelength when phi equals to pi. So at phi equals to pi, we have Compton shift maximum. So we know that delta lambda equals to h upon m0c 1 minus cos pi. Cos pi is minus 1. 1 minus minus 1, that will become 2. So I will directly write down delta lambda equals to 2h upon m0c. And if you will calculate this value, already it is given that h upon m0c equals to 0.024. So 2h upon m0c will be 2 times this. So it will be 0.048 angstrom. Now, wavelength of scattered photon we denote that by lambda dash. Lambda dash will be lambda plus delta lambda. We know that delta lambda equals to lambda dash minus lambda. So lambda dash will be lambda plus delta lambda. So here lambda we know. Lambda, it is given to be 4 angstrom in the numerical. Delta lambda we calculated, which is 0.048 angstrom. So this will come out to be 4.048 angstrom unit. Now what next we have to find out is maximum kinetic energy of electron. So maximum kinetic energy of electron, it is given by hc by lambda, that is energy of the incident photon, minus hc upon lambda dash, that is the energy of the scattered photon. So this is hc common 1 by lambda minus 1 upon lambda dash. So substitute the values. H is 6.64 into 10 raised to minus 34. C is 3 into 10 raised to 8. Lambda is 4 angstrom minus 4 into 10 raised to minus 10. I will convert in meters. Minus 1 lambda dash is 1 upon 4.048 into 10 raised to minus 10. So do these calculations and you will get this value 5.87 into 10 raised to minus 18 joule. Try this out. If you don't get this value, just write in the comment box. So this is the maximum kinetic energy of the electron. Generally, we find out the values, kinetic energy of elementary particles in terms of electron volt. So you can convert this in electron volt by dividing it by 1.6 into 10 raised to minus 19. So I will get this around 36.68 electron volt. Okay, so this is the value of maximum kinetic energy. Now they have asked to find out what is the velocity of electron. So second part, we have to calculate velocity of electron. Now electrons are fast moving particles, and at times they may have a velocity comparable to the velocity of light. So do we have to use non-relativistic expression of kinetic energy like half mv square, or we have to use relativistic expression of kinetic energy? How to know that? So first, what you do, find out rest mass energy of electron. So rest mass energy of electron, it is given by m0 c square. M0 is mass of electron, that is 9.1 into 10 raised to minus 31. C is 3 into 10 raised to 8 square. Generally, rest mass of energy of electron, you all should know the direct value. The value is 0.51 MeV, million electron volt. ये value याद ही करना है. Rest mass of electron m0 c square equals to 0.51 MeV. Million electron volt. So ये याद ही रखो. If you don't know, then you can just calculate using this formula. So that means it comes out to be 0.51 into 10 raised to 6 electron volt. Now this is the rest mass energy of electron, and we know the maximum kinetic energy of electron. So as we can see from this 2, we know that kinetic energy of electron, it is very small as compared to its rest mass energy. So when this is the case, that kinetic energy of electron, it is very less as compared to its rest mass energy, then in that case we have to use normal non-relativistic formula, that is half mv square, for finding out kinetic energy. So kinetic energy equals to half mv square equals to half divided by m multiply by m. So I will multiply by m, so I will get m square upon m. So m into v, it is nothing but p, so it is p square upon twice m. So kinetic energy half mv square equals to, we know the velocity now, we can substitute the value of velocity. Wait, half mass of electron we know, 9.1 into 10 raised to minus 31. Velocity we have calculated. Velocity we have to find out. V square. Kinetic energy we know. Kinetic energy is 36.68, or we will take the value in joules. Anyways, we have to convert. So 5.87 into 10 raised to minus 18. So V square will be equals to 5.87 into 10 raised to minus 18 into 2 upon 9.1 into 10 raised to minus 31. So if you will find out this value and then take square root of this, you will get the velocity, that is the maximum velocity of electron. It should come out to be 3.59 into 10 raised to 6 meter per second. So just try this out. If you are getting the same answer, if you don't get, just let me know. Now let us solve one more simple numerical based on de Broglie waves. So here we have a free particle of mass m is confined to a region of length L. The de Broglie wave associated with the particle is sinusoidal in nature, as given in figure. The energy of the particle is, so we have to find out energy. This question was asked in JAM Physics 2013, and this is the figure which is given. So see the figure. This distance is L by 3, this distance is 2L by 3, and this distance is L. Now if you check the complete distance L, it is nothing but this wavelength lambda plus half of lambda. So I can write L equals to lambda plus lambda by 2 plus 3 by 2 lambda. So I am getting L equals to 3 by 2 lambda. That means lambda, it is equals to, I will shift this 2 to here, 2L upon 3. So I am getting lambda equals to 2L by 3. Now we know that de Broglie relation is P equals to H upon lambda. So H upon value of lambda is 2L by 3. So 2L upon 3. So I'm getting 3H upon 2L. Now kinetic energy, it is given by half mv square. So now you divide by m and multiply by m. So I have simply multiplied by m and divide by m. So m into v, it is nothing but p. So m square v square will be p square. So I'm getting p square by twice m. So remember this formula also for kinetic energy in terms of p. So E equals to p square upon twice m. Write down this formula somewhere. Make a book. At the end you can write down formulas so that you remember those formulas. So E equals to p square by twice m. I know the value of p. P, it is 3h upon 12. So 3h upon 12 square upon 2m. So I will get 9h square upon 4l square upon 2m. So I am getting 9h square upon 4 to the 8 m l square. So final answer is E equals to 9h square 8 m l square. This is the final answer. Okay then, thank you.